Welcome back everyone. In this lesson I'm going to teach you how to access pointers from assembly. So when I say pointers I mean C pointers, okay? I've created a new file in our project called pointers.c. Please if you could do the same, and we're going to be starting this lesson now. So first we're going to include stio.h. We're going to reference the extern assembly function we will make shortly. It's called ASM change val. And it'll take a integer pointer, okay? And it'll basically change the value of that pointer, okay? Next we'll have our main function in C. We'll say init val equals 50, and then we'll call ASM change val. We'll pass the address of the val variable so that it becomes a pointer here, okay? And then we're just going to print the new value out. And I'm going to show you how you can change that value, okay, in assembly language. So this is how the C program should look. So please write that program, or you can check the video description for the source code. So next we're going to create a new file called pointers.asm. And we're going to say bit 64 so that it's a 64-bit program. We're going to say global ASM change val because we're going to create that function and we want it to be public and accessible. In our text section, as you know, that's where all the code goes. So we're going to say ASM change val, and we're going to say move dword RDI 123. So this will change pointer into 123. It's essentially like doing that in C. So how does this work? Well, we know that C passes the first argument in the RDI register, the second argument in the RSI register, and so on. And it uses all the registers up, okay? Well, most of them, quite a lot of them, before it will rely on the stack, okay? So since the ASM change val only has one argument, we know that that pointer value, the address, is in RDI. So when we say ASM change val ampersand val, it basically passes the address of the local val variable into the RDI register. And then obviously, by using these two brackets, we can basically say, set the value at this memory address. So let's say the memory address was this, it would set the value at that memory address location to 123. Since it's RDI, it'll resolve whatever's in RDI. So like, for example, maybe this is the address of val, for example. It'll resolve it to that address, and then it'll set it to 123. Do you understand? So RDI is the address, in this particular instance, is the address we want to set. And we basically say set that address to 123. And since RDI points to the local variable called val, it has the address of val, that's the address that gets changed. dword, that means 4 bytes. Okay? Word means 2 bytes, dword means 4 bytes, qword means 8 bytes. Okay? So move the integer 123 into the value. Nice and simple. And then obviously, guys, we just return. Okay? And if you wanted to return an argument here, of course, as you know, you could set RAX. That would be the equivalent of returning an integer. Okay, so let's test this then, and we're going to see if it works. So we're going to have the terminal. We're going to say NASM-F alpha64. And we're going to say pointers.asm-o pointers.o. We're going to say gcc pointers.c pointers.o-o, and we're going to say pointers. And we can see that it's now created that pointers executable, so we can run it. And look what you see, new value 123. So you can see that that has successfully changed the pointer. Okay, so let's make it more difficult. Let's say that it's a pointer of pointers. So let's say it takes a two-dimensional pointer like this, for example, yeah? And what we can say in this particular case, we can say init pointer equals ampersand val. And then we can pass the address of the pointer, okay? So this would basically become a cast to this, okay? That's what will be passed into the change val function here, okay? So in this particular case, we're passing the address of the pointer, not the address of the value. Okay. So in this particular case, what this line of code now does is it changes the pointer value. That is where the pointer is pointing. Okay. It no longer changes the actual value that the pointer is pointing to. Okay. So if your intention here is to change where the pointer points, then this can stay the same. But obviously we don't want to do that. We want to do something like this, right? So that we don't change the pointer value, we change the actual value of the memory that the pointer is pointing to. And since we now have a double pointer passed into RDI, we obviously need to deal with this differently. So how do we do it? Well, you can basically do something like this. You can say move RDI, RDI, and then this can stay the same. So we get the value of where RDI is pointing, which will give us the address here, okay? And we put that into RDI, and this line can stay exactly the same because at this point it's now just a normal pointer, guys, okay? So let's try and compile that then. So we're gonna reassemble it, recompile it, we're gonna run it, and now again we can see new val123. So you can see how that's working. So that's exactly how you go deeper in the pointers, okay? And this could go as deep as you like. You could have like 3, 4 dimensions, 5 dimensions. You would just keep running this same instruction until you get to the lowest part, right? Do you understand? So that is how pointers work, guys, in assembly, and how you actually access them. So let's take another example then. We're going to create a new example now. So we're going to say extern void ASM print char. So this is going to take in a string, which again is a pointer, guys, yeah? And it's going to take in an index of which character to print, okay? So let's make an example of this. We're going to say const char hello equals hello world. So again, it's a pointer, guys. It's a pointer to this read-only data, okay? That's what it's a pointer to. And we're going to say ASM print char. Or I should say ASM get char, let's say, so we don't have to deal with the printing stuff in assembly. So we're going to say ASM get char, okay? And we're going to pass in hello. We're going to pass in index 1. And this should give us E, right? So then we can say char C equals ASM get char. And make sure you change the return type to a char. And then we're just going to print out the character index 1 equals %C. And then this should work, guys, okay, once you've written the assembly. So let's head into pointers.asm so I can show you how that works then. So we're going to start by saying global ASM get char. That makes it public. And down here, we're going to say ASM get char. Now, RDI is the actual string. Okay, string pointer, I should say. And RSI is the index, okay? So remember, RDI holds the address to the hello world, okay, where the hello world is stored. So let's just do a test a minute then. We're going to XOR REX, and then we're going to move AL, so it's the lowest 8 bits, okay, because we're only returning a char, remember. And we're just going to say move AL, and we're going to say these brackets RDI. So what will this do, guys? This will return the very first character, okay? Because obviously, if RDI contains a pointer and contains the address of the const char, you know, the address of hello world, basically, then accessing it this way will pull out the first byte. Because it basically says, go into the hello world address, pull out first index. That's what it says. So now we can just return, and we can just test this for a moment just to see if it works. So we're going to get this back up. We're going to run the NASM, run the GCC. We're going to run pointers again. And yeah, you can see index 1 is H. Now obviously index 1 is not H. I was just demonstrating that this is the first index. Do you understand? So let's say we want to access the index they provided. So how would we do that? Well, it's so simple, guys. You just say, move the pointer to the correct index, and you just say, add RDI, RSI. Because we know RSI contains the index. And we know that the size of a char is 1 byte. Now, if this was like an array of integers, because arrays work the same way as this, guys. It's exactly the same thing. You know, if we had a pointer to an array of integers, it would be the same rules as the char, okay? The exact same rules, except you would multiply by the actual size of the data type, okay? But in our case, we don't need to multiply because a char is always 1 byte, so we can just add straight to the RDI, okay? Everything else can stay the same because this will move the pointer to the correct character in the string. And then we can just pluck it out just like we did with the H. So if we now run this again, we should see E. So let's compile this again. And there we go, we see E. So that's perfect, guys. So yeah, that's how it works basically, guys. And well done. You've now just made it so we can pull out anything. And again, this can work with any type of pointer, guys. You know, you can have an integer array, an integer pointer, anything you want. It's the same rules, the exact same rules. So I'm just going to leave a little comment for you. Heads up, if you use an array of inits, multiply by 4. Okay, that's the rule. So you multiply by 4, okay? So RSI comes in, it says index 1 or index 2, multiply it by 4 bytes. Because obviously, in an array of integers, they're 4 bytes per index. Do you understand? And since this is assembly, it doesn't follow the same rules as C, so you need to multiply it by 4 bytes. If you know the data you're passing is 4 bytes per element, you have to multiply the index by 4. Otherwise, you're going to offset incorrectly because you'll treat it the same way as we treat an array of bytes, which is what we're doing here, okay? So yeah, congratulations, guys. I hope you really enjoyed this lesson.